The synthesis of serine begins with 3-phosphoglycerate. Now, where is 3-phosphoglycerate coming from? Well, that's coming from glycolysis. Recall that in glycolysis, we go through a series of steps to produce pyruvate. In glycolysis, we divide it into two phases, the investment phase and the payoff phase. In the payoff phase, one of the intermediates is 3-phosphoglycerate with the following structure. So 3-phosphoglycerate has a phosphate on that third carbon. It has that carboxylate group on one end, and it has this hydroxyl in the middle. Now we have to turn this into serine. But before we even turn it into serine, what does serine look like compared to 3-phosphoglycerate? Well, serine, it's going to have a carboxylate group. It's going to have an alpha carbon with a carboxylate group. But then it has to have an amino group on that alpha carbon. And then for the R group for serine, we have to see a carbon and then another carbon as CH2OH. So overall, serine is going to be a 3-carbon molecule. So since we have that carboxylate group already on serine, the next step is to think about how we're going to get that amino group, because there's no amino group, and serine is an amino acid, so it needs an amino group. So the first thing we're going to do is we have to get rid of this hydroxyl, because it's on our alpha carbon of what's going to be serine. How do we get rid of this hydroxyl? Well, first, we have to oxidize it. We're going to oxidize it, and we're going to create a double bond right over here, and we see that happening right here. So we use NAD plus as an electron carrier, and we reduce NAD plus to get NADH. And this is done by 3-phosphoglycerate dehydrogenase. It's a dehydrogenase because we're using NAD plus. So once we oxidize the hydroxyl, we get this oxidized version where we see this double bound oxygen, and this is referred to as 3-phosphohydroxypyruvate. Now the next step is we have to add that amino group. Well, now we are able to add that amino group from glutamate. So glutamate will act as the amino group donor, and when glutamate donates its amino group, it's converted into alpha-ketoglutarate. In biochemistry, we often see the interconversion between double-bound oxygens and NH3s. So here, we're going from a NH3 to a double-bound oxygen. So here, we're going to go from a double-bound oxygen to an NH3. This is a very common reaction we will see from double-bound oxygen to NH3. It happens between glutamate and alpha-ketoglutarate, and that's what's going to happen over here. So the 3-phosphohydroxypyruvate will gain that amino group right over here. So now we've got phosphoserine. We're almost there. We've got our alpha carbon, we've got our carboxyl group, we've got our amino group. Now we just have to figure out the situation right over here. We need to get rid of this phosphate. And when we get rid of this phosphate, we'll be left with serine. So let's go down here how we can get rid of serine. Well, in order to remove the phosphate, we always use H2O, and we utilize a phosphatase. So we're going to utilize phosphoserine phosphatase. We use H2O, we remove the inorganic phosphate, and we're left with serine. So we lost this phosphate over here, but over here we gained an OH. So we got our R group for serine. Once again, this is our alpha carbon, our carboxyl group, our amino group, and this is the R chain. And so getting serine is a super straightforward mechanism. You start off with 3-phosphoglycerate, you convert to 3-phosphohydroxypyruvate, because first you want to get rid of this hydroxyl. And first, when you oxidize it, you get this double-bound oxygen, and we often see this interconversion in biochemistry where you go from double-bound oxygens to amino groups, and that's exactly what's going to happen here. Glutamate donates the amino group, and it's converted into alpha-ketoglutarate via phosphoserine phosphatase. And then we simply remove the phosphate, and now we have serine. So it's just important to note what the reactant is. So we start off with 3-phosphoglycerate to end up with serine. And that 3-phosphoglycerate is coming from glycolysis. And now serine can go on to make both glycine and it can make cysteine. So serine can essentially go on to produce other amino acids as well.